Okay then, YouTubers, it's Wednesday, 24th of January, bit of midweek physics fun, looking at optics with year 10, thinking about dispersion. So I've got two light sources here. This one is an LED ray box. Look, if I take my single slit out, you can see there's a bluish tinge to the light. This one is a filament lamp, so 12-volt bulb. So that's looking a little bit yellower. That's a normal, typical source of light. And then I've got two glass triangular prisms. I've already preset them, because if I look, I've got them ready to make what we call a spectrum. So we're seeing light enters the prism. It's refracted once at the boundary, so it slows down. And then it gets to the second boundary and it speeds up. But all of the different wavelengths of light will react differently to the prism. So blue is the most, and so we end up with this spectrum of colour. And you can see a really clear spectrum of colour. If I try the LED ray box, now I can see still a clean set of colours, but there's still white in the middle. Now what I was really trying to do is just compare how well the LED ray box works compared to a standard filament lamp that should be a continuous spectrum, but the LED ray box might not be. Now if we take out a little bit of the light, it's interesting because personally I can see better, and I can see it's really looking good. There's a whole spectrum of colours. My camera phone is struggling, it's coming out white, isn't it, here? But I'm seeing this really lovely spectrum of everything. But here on the LED ray box, it looks okay, but I'm not seeing that same level of a continuous spectrum. I think by optically looking with my own eyes, I think the green's a little bit missing. So whether that's to do with that it's an LED rather than a continuous spectrum out of a ray box of light, just a normal filament lamp, there is definitely a difference. I think that colour, I take them away and it's a little bit brighter. So remember how a camera phone works. The photons of light, they've got to be enough going on the sensor. I can't really control the aperture, the phone's doing it for me, but I think you can see that this is a better spectrum. So it's a really nice little demo to look at, think about in class. So compare the two light sources. Now the next step of course is to use like a handheld spectrometer, but then we're going into A-level physics. So for GCSE physics, that's quite a nice one to think about how in the olden days LED ray boxes, this one, weren't quite as good at providing all of the colours. And you can clearly see actually if I take the slits out, I think if I was sort of thinking about what would I like in my living room, well I would like this type of light. If I was thinking I'm in a a hot rod race and I want to light up the bottom of my car, maybe this is a bit cooler. It's got a blue tint to it, hasn't it? But this is a natural light, which is why probably it's better.